Hi, so this is question 97. Calculate the theoretical yield of C6H5Br when 15 grams of C6H6 reacts with 35 grams of Br2. And that is the equation of reaction over there. So we're supposed to calculate the theoretical yield, that is the amount of this compound here, bromobenzene, that is produced. As to calculate the amount, probably in grams. That would be good. So that would mean that we would have to compare bromobenzene to either one of the reactants that we have here so as to then calculate, all right? So we compare the bromobenzene with either benzene or we compare bromobenzene with bromine, okay? So you compare it with one of them, and that's how you get the right answer. If you have to compare it with the other one, you get an answer, but it will be wrong. So you have to pick the right one. So how do you know the right one to pick? Well, you need to compare bromobenzene with the limiting reagent. So that brings us to getting the limiting reagent. Otherwise, it won't be nice. So how do we get the limiting reagent? Let's quickly get the moles of these two reagents we have here. We're going to get the moles of benzene and we're also going to get the moles of bromine, okay? So number of moles of C6H6 is the mass divided by the molar mass. Now what's the mass? 15 grams. Divided by the molar mass is about 78 when you calculate it. That's 6 times 12 plus 6 times 1. Okay? Then solving that out, you have 0.1923 in moles. Similarly, the number of moles of Br2 is 35 divided by the molar mass of Br2, which should be around 159.8. So you do that calculation and you have this in moles. Now, after getting the moles, the next thing to do would be to divide the number of moles by this number here, 1 and 1. That's the stoichiometric coefficient. Okay? So if you try that, you end up having the same thing since you're dividing by 1. So you don't have much difference there. But then whatever you get, we'll then look at the two values and find out which of the values is smaller. In this case, it's going to be this one. That's the smaller one. That tells us that benzene is our limiting reagent. And this is a revision on how to calculate limiting reagent. I hope this is clear. So after getting our limiting reagent at benzene, it means I'm to compare benzene with bromobenzene. Okay? So from the balanced equation, I can see that 1 mole of benzene helps to produce 1 mole of bromobenzene. Yeah. So that just means that if I have 0.1923 moles of benzene, then it will produce the same 0.1923 moles of bromobenzene. So the number of moles of bromobenzene that would be formed is just 0.1923. That's it. But that's not all. This is just the number of moles. The theoretical yield, it would be good to leave your answer in the mass format. So let's get the mass. The mass of bromobenzene would be number of moles multiplied by molar mass. That is this number of moles here multiplied by the molar mass of bromobenzene, okay? Now, what is the molar mass of bromobenzene? Let's quickly get that. Molar mass of C6H5Br is just equal to 12 multiplied by 6 plus 5 multiplied by 1 plus whatever Br is, 80. When you add all that, you should have 156.9. Yes, that is this one. grams per mole. So we're almost done. We just have to plug that in here now, right? To get the mass. 0.1923 multiplied by 156.9. That would give us 30.17 grams. Okay, so that would be the answer to this question. Now, of course, you might have observed that I'm getting a 0.9 here, but then this is 80. But you understand this process, right? Just follow it and add it up. Whatever you have is what you use for the next step. Okay, our answers are not going to be too far apart, but then this is the process and it works every time you use the right values. All right, so that's that on 97. Let me know if you were confused at any point. Let me know in the comments. If there's anything you did not get, clearly, let me know. And you can give this video a like if it was helpful for you as well. And I'll see you on 98. Bye-bye.